and welcome back to Algebra 1. Our goal for today is to continue working with our solving equations and inequalities when we have a variable that starts on both sides, and more specifically today we're going to focus on inequalities. So we're going to start with one of our four inequality symbols, and on both sides of that inequality symbol will be a letter or a variable to begin with. Please remember, we need to think about our flip, no flip rule as we get to our multiply and divide inverse operation step. This is the biggest place where we're still making mistakes when we do our activities throughout the week and take our assessments each week. So please make sure you're thinking about that throughout your solving process. Since we are going to be starting with variables on both sides, remember that our variables could eliminate during getting our variables on one side portion of our steps, creating what's called a special case where we could have all real solutions and no real solutions. Please be careful with these inequality problems. For these special cases, it's trickier to identify those true and false statements. I really need to understand what my symbols mean. Right? Do I have a less than? Do I have a greater than? Do I have a less than or equal to? Do I have a greater than or equal to? Because if I don't understand what the symbols are, I'm going to have a hard time saying if the statement is true or false. So make sure you're studying what each of those symbols means. When it's pointing each direction, what is its actual meaning? When we have special cases, our graphs will look a little bit different. Right? So in this case, we could have a variable, an inequality statement, and a number. In that case, we'll have an open or closed circle and a shading in a direction. We could have no real solutions, which means my graph would stay completely empty because nothing on the number line works. And I could have all real solutions, which means my entire number line should get shaded because every number on the entire number line is technically a solution. So number 5. We want to solve here for the variable n, if possible. And if we get solutions, can we make a picture version of the solution? So 4n plus 6 minus 2n is less than 2 times n plus 5. All right, we have a place to expand here using our distribute property. So we want to start there first. No distribute here in the front, so we're bringing down 4n plus 6 minus 2n unchanged. All right, 2 times n would just give us a 2n, and 2 times 5 would give us a plus 10. All right, from here, we have some simplifying we can do in front of our inequality sign by combining like terms. 4n minus 2n would give us a 2n plus 6. All right, from here, we want to get all our n terms in the same location. So I'm going to take this back, n term, move to the front by subtracting a 2n from both sides. 2n minus 2n plus 6 is less than our 2n plus 10 minus 2n. And I could have put the subtract 2n before the plus 10. All right, these will eliminate or cancel, bring down our 10. Over here, these are also opposites. They would eliminate, leaving us with 6 is less than 10. All right, since all of our variables disappeared here, we have a special case, and we need to check to see if it's a true or false statement. This is a less than statement, so this is true. 6 is less than 10. So our solution here would be that we have all real solutions, which means my entire number line represents things that are solutions and need to get colored in. So from negative infinity all the way to positive infinity would be our solutions here. All right, number 6. We want to solve for the variable y when we're told 2y plus 3 is greater than or equal to 3 times y plus 7. So we need to start here with our expanding using our distribute property by sharing our 3 to the y and to the 7. 2y plus 3 is greater than or equal to 3 times y would give us a 3y, and 3 times 7 would give us a plus 21. All right, no like terms to combine here, so we want to get our y's all in the same location. So I'm going to take this y and move it to the front by subtracting a 3y from both sides. 2y minus 3y plus 3 is greater than or equal to our 3y minus 3y plus 20. All right, 2 minus 3 would give us negative y, or negative 1y plus 3 is greater than or equal to 21. Since our y's didn't cancel on both sides here, we don't have a special case, and we're going to solve, and we're going to have a series of solutions that are either greater than or equal to something, or maybe less than or equal to something. All right, 2-step here. We need to get rid of the add 3 first by subtracting a 3 from both sides. And that will leave us with negative 1y is greater than or equal to 21 minus 3 would just give us an 18. All right, our next step is our step where we have to check to see if it's a flip, no flip. If I'm going to divide here by a -1, since the one I'm dividing by is negative, I also have to flip-flop the direction of the sign to make sure I get the correct solutions. If I don't flip here, I'll have this step and my answer step will be incorrect, plus where I shade and where my arrow points will be incorrect in my number line. So a no flip will result in 4 things actually incorrect, so be careful. -18, -19, -20, getting smaller. -17, -16, getting bigger. If I'm typing on a computer, I'll have a text box here to fill in with that -18. All right, closed in circle. And we should be shading to the left, not the right. And if I forget to flip, these two will be wrong. My shade and my arrow will be wrong, so be careful. All right, you need to finish the on your owners in your packet. Hit pause here. All right, hopefully at this point you have finished your on your own page of your packet, so let's go through these. All right, number 1, we should have a 5 equals x, or I might have an x equals 5. All right, number 2, we should have an x equals 12, or we might have a 12 equals x. Number 3, we should have an x equals 4, or again, we might have 4 equals x. Number 4, we should have an x equals -5, or we might have a -5 equals x. Number 5 is a special case, all our x's cancel, leaving us with a true statement. So we should have all real numbers are solutions, so all real solutions. Number 6, we should end up with an x equals 1, or we might have 1 equals x, depending on where we moved our variable. Number 7, we should have a -11 is less than x, or we might have x is greater than -11, depending on how we moved our variable. So we should have an open circle, and we should be shading to the right. All right, number 8, we should have x is every number greater than 7 2/3, or we might have 7 2/3 is less than or equal to x. Closed in circle here at 7 2/3, and we should be shading to the right. All right, number 9, we should have -8 is not greater than 14. So no real solutions here because we end up with a false statement because -8 is smaller in value, not bigger in value than 14. All right, number 10, we should end up with -3 is less than or equal to x, or we could have x is greater than or equal to -3. So closed in circle, and we should be shading to the right. All right, I hope that helps you attack your rest of your work for this week. See you guys later.